Okay, I'm back. So this is slide number 6 of the notes for 4.4 linear equations in two variables. Video number 2. So on this page we're going to learn, on this slide we're going to do our own example. So you can follow along, take notes on your sheet, stop and do the steps with me. First step is always to graph the equation. And you use an equality when you graph the equation. So you always, when graphing the boundary line, you're using an equal sign. Okay? So you can do this in whatever way you want. If I use an equal sign, I see that y equals negative 8x plus 3. So I'm going to graph that using the y-intercept. And then I'm going to see if I can go down 8. 1, 2, 3, 4, 5, 6, 7, 8. This graph is slightly off. Sorry about that. And 1 over. That would be a slope of negative 8. Now I'm going to draw the graph. Okay, there's my graph. A y-intercept of 3 and a slope of negative 8. Negative 8 over 1. Now you notice something very important about this graph. And that is that the line is dashed. Okay? And the reason the line is dashed is because whenever you have less than or greater than, you graph it with a dashed line. The reason is because if you pick any of the points along this line, such as, sorry, that point's not quite on the line, 0, 3. If we pick 0, 3 and we put it into the original inequality, y is less than 3 minus 8x. So if we put 3 in for y is less than 3 minus 8 and put 0 in for x, we get 3 is less than 3 minus 0. 3 is less than 3. That's false. So we have to have a way of showing that the the points on the graph are not included in the solution set. So none of the points along this graph are included in the solution set. The way we do that is by drawing a dashed line. Okay, that's how you draw the boundary line. The second step is that we need to figure out the shading. Okay, and the way we figure out the shading is we pick a test point. And a test point can be any point on either side of the graph, as long as it's clearly on either side of the graph. So I'm going to pick, I think I'll pick negative 2, 4. Negative 2, 4. And then the next thing you do is you plug it in to the original inequality. Okay, so the original inequality is y is less than 3 minus 8x. So I'm going to plug my point negative 2, 4 in there. So if I plug in 4 for y and negative 2 for x, I have 4 is less than 3 minus negative 16. I'm going to go to the right here because I'm going to run out of room otherwise. So 4 is less than 3 plus 16, and that is not true. Oh, yes, it is, sorry. 4 is less than 19. Okay, that's true. What that tells us, you guys, is that our shading is going to be on this side of the line. And the reason it's going to be on this side of the line is because when we plugged in a point on this side of the line, it worked. So, if you plug in a point on one side of the line and it works, then you know the shading will be on that side of the line. If you plug in a point on one side of a line and it doesn't work, then you shade in the opposite side of the line. So, for example, if I wanted to pick the point 2, 5, if I plug that in, I would get 5 is less than... I would get 5 is less than 13. I worked it out right here, but you can pause and take a look at it. That's false. So I know any other points on this side of the line will be not be in the solution set. Okay? So those are basically the steps. The dotted line, the dashed line, shows us the boundary of the solution set, and every point on the left side of this dashed line should work. Up here under step 1, I probably should have put draw the graph. If it's less than or greater than, it's going to be a dashed line. Right? If it's less than or equal to or greater than or equal to, it's going to be a solid line. So we have that recorded here. Okay, so I'm going to let you read through these steps. They're basically what we just wrote. Highlight or circle anything you need to as you read through it. Okay, here's just a few important points. Okay, so what you might notice as you go along is there is a pattern around the equations and which way you shade up or down and the inequality, so you can look for it as you go. If you have any questions you'd like to ask, please write them below so you remember to ask them to me or a peer. Okay, here's another example. So note, this equation is already in y equals mx plus b form. And to graph it, to graph the boundary line, we're going to graph y equals 1/6 x, y equals 1/6 x minus 1, right? So we're going to plot the y-intercept, which is -1, and then we're going to use the slope. So we're going to go up 1, rise, and over 6. 1, 2, 3, 4, 5. 6 is going to be over here. Okay, so this graph will be a little bit of an approximate graph since our other points are off the graph, but that's okay. So we'll draw the line, and notice this is a greater than, so it's going to be a dashed line. Okay, there approximately is our line. So we graph the line, it should be dashed because it's a greater than. Now pick a test point and shade on the appropriate side. Okay, the easiest test point is always 0, 0 if you're very clear about which side of the graph it's on. So if I try 0, 0 in my equation, remember it's the original equation, I get, y is greater than 1/6 times 0 minus 1, and I'm going to let y be 0 also because I'm substituting the point in. Okay, so I get 0 is greater than 0 minus 1, or 0 is greater than -1. True or false? 0 is greater than -1. So since 0 is above the line, my shading is going for this graph is going to be everything above the line. Now if I want to double check it, I can pick a point down here. Let's say 1, -2, and I can plug it in and verify that it doesn't work. Okay, so if you look down here in the bottom, I took the point 1, -2, and I plugged it in, and I came out with -2 is less than or equal to is greater than, -5/6. That's false. -2 is not greater than 5/6. So I verified for myself that I have shaded on the correct side of the line. Okay, so this last step down here where it says check by picking one other point. To make sure it works, I picked one on the other side to make sure it doesn't work. Okay, good enough. Okay, you do this next graph. Y is greater than or equal to -3. Pause and do it, and then you can start up the video again. I'll show you the solution. Okay, there's your solution. Please read steps 1, 2, 3, and especially make sure to read this piece right here. Okay? Okay, well, I think a slide got left out. Actually, slide 11 is a duplicate of slide 10, so we'll skip it. So, if you want to see some more examples of this, look in your book. Here you go. And this is the homework to do, or classwork, whatever it ends up being, to practice some of these problems. You will need graph paper and a straight edge. Okay, don't do these on regular paper. Also, one other super important thing. Don't forget that when you multiply or divide a negative number by an inequality, in an inequality, you have to reverse the inequality sign. So, for example, if we had something like negative 3x is greater than, 15, and we want to divide both sides by negative 3, when we do that, we have to flip the inequality sign because we're dividing by a negative. So remember, if you're going to solve these for y, when you graph them, when you divide by a negative, you need to flip the inequality sign. Okay, that's it.